So while the projector is warming up, we can start already. So today is the last day of software engineering methods lectures, and today we are going to talk about all the reasons why the stuff I've been talking about the last 12 lectures maybe sometimes difficult to use, even contain faulty information, or be something that's not really usable in many organizations. After the lecture, after this topic, I'm also going to say a couple of words about the exam itself, about what sort of questions to expect, what sort of structure I'm used to having on the lecture. So, the last 2 weeks we've been talking about testing. Before that, we talked about the agile methods, development cycles really, and before that about design, making and use case analysis to go from requirements to something that's implementable. So basically, we have covered all the steps from gathering requirements to testing work. And this last only feature I'm going to show this morning about testing is more or less about how the testing work is structured. The organizational level, the upper management, people in position to make changes or put requirements on organizations are giving organizational level documents, framework including test strategy, test policies, the project level employees, people where the project manager is responsible for developing or devising a test plan, managing and monitoring and controlling the application of that test plan, and overall gathering feedback for the organization to know if they need to make some changes for the future projects. Also on the actual execution level, fundamental testing level, there's activities, static processes, dynamic processes, meaning that things that the organization test people always do, and things the organization does according to the test phase or test type of project they are doing. So overall, the upper management steers the middle management, which steers the workers, testing people, who report to their managers, who compile larger reports to the upper management. And that's basically it. It may seem like a simple thing, something that probably should happen in any case, but actually the application of feedback to manage testing work is in industry something that no one really seems to be doing. There's an catastrophe-driven development cycles, meaning that when one project fails spectacularly, that's usually the time when organization starts to see why this happened. And overall, even in those situations, the changes towards more sustainable model of work is usually just baby steps towards actually doing something worthwhile. But today's topic, it's more or less constraints of methods. It actually means that what these methods and different approaches, all the stuff I've been talking about, what are the limitations and how you actually should understand them when you're trying to use them in your professional work. Of course, the entire idea comes from the definition of information system development method or software process models. It's a well, it's a philosophy for developing system, really. It's not necessarily related to anything real, so to say, that the roles and rules and approaches and different activities are more or less devised based on the people who developed the model. The best practices, what seems to be working. And overall, the idea of the systems development method is that it more or less just defines who does things, where it's done, how things are done, when we do certain tasks, what is the main idea of this approach, and why it's important that we follow these ideas. So more or less, how development is done, what tools and techniques are we going to use. What technique here meaning that what sort of an approach to take. Are we going to use customer feedback? Are we just doing brainstorming? Are we going to vote about things? Are we going to nominate a cabinet of 15 people making proposals for the rest of the people to vote, or what? It's basically just an approach into accomplishing a complex task which is more or less doable individually by the really experienced or really talented, skilled people. So more or less help people to overcome the difficulties with certain tasks. And of course the tools here are more or less just instruments to perform development engines, development environments, different sort of illustration tools, design tools. UML is a universal modeling language, is actually a tool which is used to large degree. Well, it's kind of universally used, but also only some parts of it. So, and also because these approaches, methods or models, they are more or less philosophy. They also require that you have to believe in them. It's the beliefs. These mean that what is considered good value, what is considered really good approach. Why should we do that? For example, daily meetings, the Scrum meeting, or the first thing in the morning when the developers come to work around 9 a.m. They all gather around to one office where they each explain in a couple of minutes what they are going to do today, what were they doing yesterday, and what are they trying to accomplish during this week, and what are the most problematic things that are hindering them. Okay, so it works if we have less than 15 people. We can manage to get that Scrum meeting in half an hour. And, well, of course, someone might say that, okay, it's in half an hour away from productive work. So why do our developers spend the first 30 minutes every day in Scrum meeting when they can, well, get nothing done really? They give a couple of minutes worth of presentation, talk about the work, and then they will just be waiting for rest of the people to talk about the same issues, similar things, and stuff like that. But, of course, the belief that this is good comes from the observation that's actually really useful, because then every developer knows what the other guys are doing. They also know if someone else is having the same problem, or if someone might get note on that, okay, I actually have to hurry this up because the other guys are having problems with the component I should be doing. So it's efficiency factor. It also is a reinforcement or work morale factor, telling most of the people who have been struggling to get anything done. It tells them that, okay, they aren't worse than other people. Other developers have also problems in it. In development work, they are unable to solve some problem, or they are struggling with the same performance. So basically, that's the belief that it's a good thing. It also it's a value thing, really. If we want to promote communication, people telling each other honestly about their work, or not giving empty promises or just pushing things back into the work pile, then we want to promote working together, cooperative working. We also want to promote that people should seek advice or seek help on implementing difficult things. And of course, if we have to speak, the developers have to speak about their problems or speak about their expectations every morning, it may be something that actually promotes people talking. It also shows that the organization doesn't have any really strict problems with internal exchange of information. That's actually one really interesting thing, because in some larger organizations, it's a bit rude to say, but some companies run by an American corporate lawyer system. They are really strict about what you can say about your current work. One guy may be just a guy who's updating the intraweb with the current menus of the restaurants nearby, and it's a top secret work which you can't talk about to anyone outside, simply because some lawyer had decided, our value as a company will go up if we classify every activity top secret and you aren't allowed to talk about it. That's another belief. That's another value there, really. It's a bit, really conflicting value, nevertheless, but still it's a value and it's a belief in that organization that this method is actually good for us. Okay, so the other thing mentioned there, the roles. They are more, developing a software product. It's more or less theater production. But instead of having shows or having any plays, you are just doing software development. You are given a role. Okay, you are the database developer. You are the user interface developer. You are the head of quality. You are the project manager. You are overseeing this task, and so on and so on. So where do these roles come from, really? Well, obviously, someone has to be responsible or supervise that anything happens, because we have several people, and usually more than 10 with 15 people, and that's the limit of how many, limit of the organization which can manage itself. After that, we have to have someone who's actually steering the work. Then all the quality managers and feedback and testers and these sort of things. These roles are more or less just abstraction, or someone thought that this would be good thing. For example, in Scrum, there are several roles like owners of certain items, or Scrum Master, being the replacement word for project manager, because Scrum Master sounds much more professional. We actually come back to this problem later, but also there's roles in rational unified processes. There's actually, in the unified process, if you go through the documentation, there's like 50 different roles for people. Like one person who's responsible for compiling a marketing documentation or marketing material from the documentation of the product. That's not a role that's immediately, I wouldn't think to appoint anyone for that role, unless, of course, marketing would come to my project and say that, hey, we need material. Someone has to give us specs on how this thing works. But still, there's a defined role for that, and it's actually a really important role. Well, as important as any of the other 50 roles, because it also says that this person here has to understand what the marketing might need or what the marketing might be using. So that's also thing the method really needs to tell. Also, I can say that basically, I can put anyone as the guy or girl or a person responsible for giving material to marketing. But if the person just starts to talk about the problems in our product, what's still missing, what we can't do, these sort of things, what the engineers usually do when they start to talk about their product. It's of course it's honest, but we all know that the marketing and honesty aren't actually compatible to each other. The marketing wants to know what's the reason why we are building it, what's the thing they can sell to customers. They aren't really interested that, okay, the system isn't able to use Asian languages, or that there's problem here and problem there and it probably crashes if the player tries to do something. They aren't interested in that. They want to know the genre, the visual idea. What are we expecting to do? How many people is this industrial robot going to replace? Or what can it actually do? Can it just weld stuff, or could it move around carts, and can it pick screws out of the line of bolts and stuff like that? And finally, what phases we are doing, what are included in what order? Obviously the phases of waterfall are in every model. You have to collect the requirements, you have to do some sort of design, you absolutely have to do development work. Testing is, it's necessary for every commercial project, and you have to launch your product if you want to ever have €1 out of your work. Of course, these are mandatory tasks. But if going back to the agile processes, we saw that there's actually several different ways of doing things, like what documents, what designs are approved by management, what you can do by yourself, when are the milestones, how long iterations are we going to have, when do we do the backlog activities, tasks like these. So these are just parts of an orchestrated play called constructing information system. It's, you aren't acting, you are just developing software, but still it's more or less why do we want to do it this way, what are the roles, and what sort of orchestration are we going to have with these roles so that we get the result we wanted to. So, of course, these approaches come in two different two different packages. There's formalized methods and there's methods in action. The formalized method here is the one I've been talking about. It's the, more or less talking about for the entire course. And this is the only thing we can actually teach in university. Because the formalized method means that we have really strict rule book. It means that we have the roles, the phases, all the different activities defined to a degree that it's reproducible in any organization. It means that it's explicitly documented, and there's, so that we can actually teach someone without actually putting them into a real organization doing something. And, these can of course be developed in-house or commercially. The commercial methods are something like Scrum, Rational Unified Process. Things you can hire an expert to teach the organization. If it comes from in-house activities, it's more or less that someone has decided to document a couple of successful projects and define a model which more or less would be usable. Things like Six Sigma and the test process improvement model, they both are originally in-house documentations for, activities. If I remember correctly, the other one was IBM and the other one was, it doesn't matter, but anyway, it was a large Dutch software company. They originally developed these models to their internal use, but the people developing it actually had the foresight to talk about their approach in conferences and other meetings with professionals, and it started to roll downhill from there. Okay, so that's the formalized method. That's the one thing I'm talking about in these slides. But actually what you are going to experience when you go to the actual software company anywhere is method in action. It means that it's the formalized method, or basically any method, used as it's really used in practice. Meaning that the difference here being, like in the ISO 29119 test process model, is that I can talk you all day about the benefits of actually reviewing your process, actually doing something to fix problems before they become problems. And we may all agree that it's a good thing to do, but when we go to the organization and they say that we don't have time for it, we don't have money for it, we don't have anyone who's capable of conducting the reviews or able to conduct the necessary changes, then we talk about methods in action. Of course, these are, always formed around the experience and skills of people actually doing work. It's no use trying to force a method which no one can use, or include roles that are irrelevant, or trying to get people to learn something on their own time because we are just trying to do something nice and different here. Actually, the problem that the organization tries to maintain a bureaucratically heavy or cumbersome or simply non-functioning approach, and at the same time hindering their performance, is sadly quite common factor. In many reports or scientific studies, or even personal observations from companies I've been working with, the formalized method goes out the window immediately when the project starts to run out of time or run into any sort of problem, because the applied method includes too much documentation or too many process steps to get some change approved. It means that people simply stop reporting any changes. They just, I just made a hot fix or quick fix to this problem. I didn't bother to document it because it would have been more documentation about the small change I made in the module than actually doing the fix myself. And if no one notices it, then I'm free, so to say. And the idea that it's easier to apologize than ask for permit is really unfortunate, but it happens, and that's actually the reason why documentation-heavy formalized methods may not work. Also, if there's a bug database and it has a form which has several pages after pages after subpages and subpages after subpages, mandatory fields where you have to report who found it, where it was found, the version, the day, the computer, the operating system, the development tools, what were the color of your clothes you were wearing when you found this problem. It only means that people get frustrated by filling out those stupid forms and stop reporting bugs. So that's also one reason why method in action and formalized method aren't exactly the same thing, even though the method in action may be based on something like Scrum or extreme programming. So, why do we use these methods? Well, there's several benefits of them, really. One is actually the reduction of complexity. Like I said earlier, there's several parts in software development where you have to be really experienced or skilled person to do the design by yourself. There's also problems which are really difficult to solve. Something like merging two different databases or creating a satellite to enable communication between continents. So these methods for design, for development, for quality assurance, all these sort of things, they reduce the complexity. You sort of know what you need, you sort of know how to do these things, you have kind of a roadmap to get things done. It also means that you can visibly see the process improvement, or when the product is maturing towards something that's releasable. You can measure your progress. You have the designed version of the work, so you can compare your current situation to your abstract design and see what parts are still missing. You can actually even see if you have competent people or the required competences to get your work done. You know beforehand, for example, that you need to have an application for mobile system, and if you don't have anyone capable of doing programming or mobile application development, then you might want to start looking for one before you end up in a situation where your customer or stakeholder or players or whoever start to ask about the missing mobile application or mobile platform or mobile interface for the system. It also means that if you know where you are and have an idea where you're going, you can also do division of labor. In software project, there might be up to, several hundred people working for one project. And if we would be using some laissez-faire approach, do whatever you want as long as it's related to the project, you would end up with a complete chaos. So, of course, this application of method gives you timetable, it gives you schedules, it gives you the critical path of activities that need to be done so that your project goes forward. So you can also divide your labor to people who do the design, people who are drawing interfaces, people who are trying to create the database, and people who are doing the systems programming. So for these reasons, of course, the methods are useful. There's also a couple of bit more abstract reasons. For example, the systematization of development knowledge, meaning that since we are trying to document things or trying to create a roadmap out of the best practices and activities we need to do, we aren't dependent of that one really experienced project manager or that one really experienced programmer. Of course, losing them would be a bad thing for the organization, but it's no longer a catastrophe because we have all the required information available in documented form in design documents, in the systems architecture, in the comments or the existing modules. And since we have a sort of a design for the system as an architecture, and we have the existing modules, even without the lead programmer or producer or project manager, we would know what is still missing. So if our rockstar developer or our godlike software project manager gets run over by a bus, or they decide that, okay, I just want to be a farmer in the northern parts of Finland, I don't like this software work anymore, it's not a huge loss for the project, because we can get a new person to replace that role, actually. And if we replace that role, then it's just the simple task of learning what I have to do at this point. Of course, it's not that simple, but still it's manageable exchange of information or exchange of role. Also, the standardization, which naturally comes with the methods, because we are documenting the way we work, and it creates sort of an in-house standard, or we can use external standard or method or approach to do things. We can also do the resource calculations. How much money are we going to need to develop this program? How much time would we need? How many programmers? How many testers do we have? So we know how many site licenses do we need for certain quality assurance tool, and these sort of things. These are more important to the commercial aspects. But still, we are building something that's as complex as a space shuttle. You actually really have to keep that in mind. If you are creating an embedded system where you basically have to create your own operating system and drivers and communicate with the hardware and things like that, it's really complicated. If you are developing something nice on top of Windows platform or Linux platform, or even doing a simple mobile application, if we calculate all the variables and stuff, starting from the hardware system to the operating system layer and drivers up to the middleware and, to the user interface and your own libraries, your programming languages system libraries, and your own modules, we have more variables here than in a normal standard-sized space shuttle. So that also means that if we wouldn't have any idea how much work we have to do we have to create a separate computer system, hardware platform, possibly? And do we have to create operating system? These sort of things. It would be really annoying to give any sort of a calculation to customer how much this product would cost. But because we know what we need, we have an idea on the platforms. We know what sort of things different parts are capable of doing. We know which parts are interchangeable. We know which parts are compatible to each other. We also have an idea on what sort of resources we will need. Not only for the development work, but overall to have a software business. It also means the standardization of development process here. It means that if we want to have new developer and we have a sort of a standardized approach to doing the development work, we have a sort of standardized tools because we probably are using a programming language which isn't in-house development. We also can acquire more people by insourcing, hiring through consultancy people to do development for this one project. Or we can replace people who have left the project by hiring new people, and we don't have to spend the first 3 years telling them how to do these things or how to do programming and these sort of things. Actually, this part, if we take this idea far enough, it's already happening now. Since I'm talking to, well, mostly recording system because some of you are browsing web and some of you are probably in Facebook or whatever, the information you hopefully gather from this course is something that helps you to adapt to software project in your future employees' projects. Okay, so then, well, these all are fine ideas, but why are these problematic? Well, the research community, some say that if you can't do, then you teach. Some say that if you aren't even good teacher, then you are researcher. Well, actually, that's irrelevant here, really. But the research community, or the research for these methods, is sometimes a bit spotty. First of all, there's really not that much empirical data on many of these methods, or comparison of different methods. Not because researchers are lazy, but because it's really, really annoyingly difficult to compare two approaches so that we can say that they are comparable to each other. Not only because the approaches may be really different from each other, but because all the little things like how well people get along, what are the people's competences, what are the suitability factors for different methods in different industries, actually vary to a large degree. But that's actually something that you should remember. Many of these methods are more or less defined based on best practices in one or few industries. So it's, well, sometimes based on really small amount of empirical, practical observations from organizations or companies to know how well this particular model would be working in another scenario like airplane industry or cars. So, there's a couple of points I would like to make on these problems of formalized methods, because they are really important to keep in mind when, for example, deciding on what approach to take when developing your organization forward. For example, the definition of method is one thing that's, well, problematic, since they sometimes are very different to each other. I mean, the extreme programming and the rational unified process, they are really far from each other. There's also the different activities in the different ways of doing things, like the suitability model of agile approaches. What's really usable in defense contractors' work or space technology, and what's really usable in games industry and places like these. What these methods actually define. Also, in some cases, like with most iterative models, if you read through several of them, you can start to see that there's the same attributes, same activities, same things happening again and again and again, even though they are given completely different names. So the definition of method sometimes is a real problem. For example, the problem is that if we consider some of the models we'll be using on this course and the empirical evidence, and so what do we actually define? We have the activities here, like requirements gathering and design, implementation, testing, and maintenance. Of course, these are the phases here. So we go from that end to this end, and the process matures towards the maintenance. So if we consider the waterfall, of course in this model we are defining everything here, but the waterfall isn't that good approach since it lacks the iteration. Okay, so then we take the iteration into account, and let's say, okay, we want to use Scrum. There's actually a problem here because Scrum doesn't really define requirements gathering or design. It's mostly here. Similarly with extreme programming, it's actually only defining implementation here. The rational unified process, well, it's another one actually going almost all the way, but it doesn't actually give any idea of maintenance. It just says that when you have tested the thing and you go with the launch, which happens around here, then, well, the maintenance is something else. We don't care about that. Also, interestingly, there's one other thing I want to add here. It's the small SME model. This is outside from the course scope. It's kind of a new thing. It's ISO IEC 29110. Not 9. 9 is the test model, but 0, which is a life cycle model for small and medium-sized enterprises, which is meant to help small companies to acquire projects or do enough process maturity to be able to work with larger companies. So this model here goes all the way through here. So it's kind of a, well, nice drawing really. We want to do something that's iterative. So okay, we probably would have to take the first parts of the rationally unified process here, because it talks about how we should gather requirements and do iterative design work, but we don't want to have all the 50 different roles for that work. So then we just decide to use Scrum, or sorry, this is not Scrum. We decide to use Scrum for the rest of the project, and then we just go to one part, a waterfall with the maintenance. So we are already using the ideas of 3 different methods here, and we have just barely made one product. Also, with the empirical evidence, the SME model here, it's well, it was developed for software industry in mind. These really small companies. So, and they are saying that okay, it works there. We are given this 50-page guideline on how to do that. You should do requirements analysis. You have to document your requirements. You have to do design and you should document it. You should have some metrics to make sure that your product is going towards the right direction. But actually, what we found out in our own study here, that the games industry, which is a sort of software industry, so they are kind of the same thing. The games industry simply can't use the SME model. It's on the there's small differences in game development, like late changes to adapt customer needs, meaning that this SME model, by the idea of application of SME model by the games industry experts, actually almost 30 of them, they were, God no, really, this is completely unusable. We can't do anything with that. And that's actually one of the reasons why I'm saying that the empirical evidence on usability in practice is actually rare. There's an international standard saying that if you're a small company doing development work on software area, which the games also are, it should be fine. But when you go to talk with people in the games industry, they say that this can't be done. It's too much. It's too much design before implementation. There's no way to take into account what the customers might need, or if our competition releases game similar to ours. Also, taking into account the fact that the rational unified process has those 50 different roles, what about the medium-sized companies, the companies which barely have 50 employees? Does it mean that we have to give role to each person, even those who are attending the cafeteria? Okay, you are now our assistant to our lead quality manager. Enjoy. And this, or can we only have one project, or one project per 50 people? Also, well, going into aviation and nuclear safety and stuff like that, we would be here tomorrow if we started to go into that mess, so let's skip ahead. But anyway, keep in mind that the empirical evidence isn't always there. And of course, even if we say that these models are based on best practices, that it's based on the ideas that the really experienced developers have seen when they have been doing work, and they have created this Bible of software development, which has only the best things about things. Well, it doesn't really. In reality, some of these motivations can be really political. They can be based on, well, personal experiences on some software industry, or they have political influences, or they may have commercial influences. For example, it's not that uncommon for large company like IBM or Capgemini or any company really, which works on the consultancy business for software development, to create process model complicated enough that it warrants the people from that company to go somewhere and teach people. It would be, well, kind of stupid thing really to give out your good ideas and best ways of working without asking any money about it. So that means that sometimes these models may be jumbled or difficult to use simply because someone wanted them to be like that. For like capability and maturity assessment models, CMMI, TMMI, these sort of things. They are really large, really difficult things, and sometimes not because they are measuring really difficult and complicated things, but because they want to ensure that people actually have to ask for help when using it. Also, some person might be against waterfall, or some person might be against iterative methods or agile methods in general. I know that some people were so against extreme programming approach when it appeared 10 years ago, that they are still talking about how agile approaches, pair programming, scrum meetings, daily builds, things like that are destroying quality because they are this agile approach, which is something that the young people are doing to ruin software industry for them. Well, actually, on quality aspects, the daily meetings, test automations, the scrum meetings are actually good for not only morale of the crew, but also for the quality, because people know the problems. But, well, there are people driving agendas, there are people who have opinions, people who have strong opinions. They are usually the most difficult people to handle. Also, like I said earlier, the methods sometimes drive the idea that our product isn't successful because our metrics say that it's bad, or our project isn't going forward because our developers haven't reported their weekly statistics or weekly reports. So the project is doing badly because our metric system is wrong, even though actually the program is almost finished a couple of weeks early with excess money left, simply because the developers decided that they aren't going to bother filling out the forms telling about how they feel from scale 1 to 15 or things like that. So the goal displacement here means that are we actually measuring things because we want to measure things, or are we just using measurements to see that we have enough time or resources to do things? So which is more important? The people do the metrics or the method of seeing that if we are going forward, or actually having the forward momentum of doing something. Also, the problem is that the methods aren't universal. Like I said, demonstrated on the overhead projector, some approaches simply don't work. So one universal method for systems development, it's a noble idea. It's actually one of the things that people are trying to find in software engineering. But the problem is that if we would really have a truly universal method, it would be so universal that it wouldn't do anything. Because the same method should be scalable from doing a small application for displaying the menus of the university restaurants on your mobile phone. From that to developing a security suite for a nuclear power plant or space program. So that one method or process model simply isn't going to be very useful. It's going to be so filled with different appendixes and attachments and things that may not be necessary or mandatory unless they are, that it would be a complete bungle of things that wouldn't be usable. So basically, these methods I've been talking about here, They are just recommendations, ideas what could be good approach to doing development work. Also, the third item here is the most important item of the entire course, really. The biggest factor in efficiency or in any software development are the people involved. So we can have documented knowledge, we can have documented features, we can have the system architecture. It's all very useful, yes, but we need to have competent people. We need to have people who aren't constantly worrying each other or arguing over minute details. And we need to have people willing to use the method. If the method is thrown out immediately when the project actually has to focus on getting something done, then the method is unusable. It's just excess weight on the project. So that actually also means that many of the formalized methods may be actually in conflict with the fact that people are the part that decide if this method is going to work or if this approach is, well, feasible or even anyway usable. Also, going back into the political reasons, there's some hidden motivation of methods. First of all, is to professionalize the development work. It's much easier to say that you are professional, you are wearing big adult person pants now, when you are wearing a tie and having a jacket, having your own office room, having project chart, and having meetings every day for monitoring the advancement of your project. It also means that you look nicer for your investors, and it gives confidence on people that, okay, these are real professional people. But you are, well, you are still the same person as if you were wearing jeans and a t-shirt and doing development work lying on your back on your couch. So basically, that's one motivation, to give a professional feeling to work. Also, it means that it gives developers sort of a power in strategy formulation, because it says that the developers have these and these and these responsibilities and they make the decisions on these aspects. So it's sort of a steers power from the management to developers. It's also useful to upper management, people who really aren't doing the software development work but are overseeing it, or are the people financially responsible for the company, having the comfort and confidence that, okay, our company is doing proper things, we are doing proper practices. This also is about the different certifications and standards. If we follow some international ISO, IEC 15504 certified process, and we also have the CMMI level 5, then we must be really good company and we must be really good at doing things. So it gives a legitimacy, and it gives a confidence that yes, we are doing things correctly, even if there would be real problems in the organization because of people, or because of lacking skills, or because of the tools or the infrastructure. Development environments aren't suitable. Well, also if there's a lawsuit involved, then it also leaves a nice little paper trail to go back and say which was the problem, who was in fault when the project failed. So, in conclusion, methods are important. They enable us to communicate. They enable you to learn about how software is done before you actually go into company. It also means that the companies can hire people who are already fairly competent on their way of doing software, even before they have worked for one day in the company. It also means that you can design things, you can also understand limitations, you can have resource allocations, and you can actually be fairly competent and confident when you say that, okay, this will cost us 100,000 euros, and we will be able to produce the product with that amount of money. But, like always, I've been saying, the methods aren't the correct solution in every problem. They are just best practices or recommendations on how you should be doing things. The methods should adapt to people, not the other way around. So that's actually all the course has to offer via lectures. You have still a couple of weeks of doing the project. I'll give a really fairly quick recap on the course things. So I copied a couple of slides from the first lecture. So the idea here was that you would understand the problems of modern software development. You would also be able to, well, after this course, be able to use these computer-assisted software engineering tools, the UML drawing systems or documentations and stuff like that, to define and design something somewhat comprehensive or somewhat large software and information system, or at least would be able to understand and read the UML diagrams if someone gave you one on your on the company. So the most essential contents were, besides the general understanding, also the UML, the rationally unified process, the agile methods, and how all these different things work in practice. Not only what I said, for example, today, but also have some practice on drawing UML charts, making designs for system architecture. So with the UML, we went through all the different diagram models, but of course the UML isn't the be-all end-all design system. It's more or less to help convey knowledge on visual form, meaning that if you are going to do all the different design aspects which UML offers, you would probably fill out the library with this relatively small software. So actually understanding what are the main parts, class diagram, use cases, activity diagrams, which are used in software. So there's a list of different main topics. It's just a copy-paste from slides. It's a list of main topics covered, and I can assure you that the questions on the exam are going to be on these main topics on these two slides. Also, about the exam, well, of course you can take the exam even if your project to work wasn't accepted yet. Actually, it's impossible, since the first exam, if I remember correctly, the first exam is actually before the deadline for the project due delivery. So you can take the exam even if you haven't got your project to work accepted yet. But anyway, on the exam itself, there will be 6 questions based on the course topics, and there will be 6 points per question. However, the maximum is 30 points. So you basically have to choose 5 of those 6 questions and answer them. I will be grading them from the 1st to the 5th. I will be leaving the 6th answer out. So even if you got 6 points from the last answer, you, well, miss out those 6 points. So pick wisely for those 5 answers, or clearly mark that you don't want this this answer graded as an exam answer. Also, maximum answer length is 1 A4 page per question. This means that you should distill and summarize your knowledge on the given topic, because it's not that I hate reading stuff, but it's more or less because a couple of years ago, when I didn't have this maximum answer length, I got back exams where people had been writing like 30 or 35 pages about agile development, repeating themselves over and over and over and over again. So I thought that if you, for each answer, give summary of 1 A4 page, it would be enough to understand or see what you did understand and what you didn't. Also, including the last point here, that you should focus on showing what you know and what you did understand from that topic. If it's complete guessing, it will actually cost you points if it's obvious that you are just throwing around stuff, seeing what sticks to the wall. So don't try that. And the questions are from this list, and there's a very good comprehensive examples on the exam questions on the Student Union exam archive. I heartily recommend that you go through those exams and see what sort of questions they are. They aren't the exact same questions, of course, but the similar questions. And finally, when you answer, ensure that you answer to each sub-question. So if you talk about the first part, like, for example, if the question is something like, what is UML? What does UML mean? How it works? What types of diagrams there are? And if you just answer the first part, what is UML and what's the main reason for it to exist? And don't answer the second part, what are the main diagram types, for example. Then you already lose points because, of course, the second part of that question will also be something that yields points to your answer. So answer all the sub-questions or sub-points in the question. That's something that people usually miss out. Okay, but anyway, that's that, and thank you for your presence here. And if there's any questions before exam or after that, you can come by to my office during consulting hour or send an email about your questions. Thank you.